Hi, my name is Bhuvanand Barik and welcome to my YouTube channel. Today in this video, we will be learning about information gain. In previous video, I have already shown how entropy works and how entropy is calculated. So in decision tree algorithm, this information gain is the most important thing, on the basis of which right feature is selected for splitting purpose. In a simple term, if we say which feature will be root node, which feature will be branch node, is calculated based on information gain. And how information gain is calculated? It is calculated based on entropy. So let's proceed with today's topic, information gain. As you can see on the screen, information gain can quantify the quality of a split. It means if information gain is seen, then we can understand whether splitting should be beneficial in that way using that particular feature or not. Information gain can tell us how much entropy has been reduced. It means already I have shown in entropy video, entropy is an obstacle. So how much obstacle has been reduced, that is known as information gain. And how this is calculated, that also I will be telling. For each feature in a data set, information gain is calculated in order to select right feature for splitting purpose. So let me give a brief about decision tree, how decision tree works. Like in decision tree algorithm, there are various features are present. Particular one feature will be selected as a root node, then that feature will be selected based on its labels. Once labels are seen, that is subset of labels are seen, again it has to be checked whether it has to be split further or not. If it should not be split further, then it has reached root node, leaf nodes. If it should be split further, if the data set is not pure, if mixed data is present in that, again it has to be split further. If it should be split further, then it has to be checked by using which feature, what should be the decision feature on the basis of which the rest of the splitting has to be calculated. So in that way, decision tree works. And to choose the right feature, this information gain has to be taken, and to understand the information gain, first entropy has to be calculated. Information gain is calculated post calculation of entropy or Gini coefficient for respective feature. Here one term is entropy. We have already seen how entropy works. The term comes Gini coefficient, means it's a different term. For that I will be creating one more video. I will be explaining you what is Gini coefficient and how is it different from entropy, and whether it is good or not in comparison with entropy. So as we can see, in below data set there are 10 rows for which data is present. You can see on the screen, like here, age, student, occupation, income and sale. Sale is here output column. So you can see the question mark, and we have to identify, or we have to select whether sale has to be there or not. If sale is there, then it has to be yes. If sale is not there, then it has to be no. So how the data will be calculated? Based on this existing data, it has to be calculated. So here output cell feature is having values like yes and no. You can see yes is written in green color and no is written in red color. So you can choose, you can understand in this way. If age feature is selected, then it can be split into two sets. Let me tell you here, suppose decision tree is calculating and taking age feature as the root node. If it is taken as root node, then suppose the splitting is happening, and if the splitting is happening, if it is happening into two sets, here for an example we have taken the subset which is less than 25 and subset which is more than 25. So let's see how the splitting is happening. For calculation of information gain, how the entropy is calculated? how the like information gain is calculated, that we are seeing. As we have taken like age feature. In that age feature, information gain has to be calculated. For that, entropy has to be calculated. So formula of entropy is given here. For binary classification problem, formula of entropy is given below. Here P positive means percentage of positive cases out of total cases. Similarly, P negative means percentage of negative case out of total case. So already I have shown this formula in previous video. So before calculation of information gain, first entropy of that particular root node is calculated. And if age is like split into two parts, in left branch which is less than 25, there are 6 rows in which there are 5 no and 1 yes. If you see like here 22 up to 22 the value is there. So these are only 6 values. Here in right branch we can see the data is equal or above 25. If the age is either 25 or more than 25, then it comes in right branch. So if you see here 25, 35, 38, 40, there are 4 rows, and out of 4 rows there are 3 yes and 1 no. So in order to calculate information gain, first entropy is calculated, and separately it is calculated. For left branch the entropy is calculated, and the entropy found here 0.66, and for right branch the entropy is found here 0.8. So here the formula of information gain is given below. If you see pronouns like h of s minus in bracket SB by divided by S into H of SB plus SB divided by S into H of SB. So here H of S is entropy of root node and H of SB is entropy of subset node. You can see here there are 2 SB is present, or 2 H of SB is present. It means like one is for left node, another is for right node. So S is total records in root node, SB is number of records in subset node. So let's put the formula to previous example. Let's put the formula to previous example. H of S we found 0.95. H of S means basically it is we can see H of S means entropy of root node. Entropy of root node means if the entropy of root node is calculated in the total, then it is found like 0.95 is the entropy of root node, and once it is split, again the entropy is calculated for each split. It is split into two parts. For left part the entropy is calculated separately and it is found like 0.66. Again for the right part the entropy is calculated separately and again it is found 0.80. And the number of records present in root node is total 10. Here you can find like number of records found in left node is 6 and number of records found in right node is 4. So if it is kept in the formula 0.95, which is H of S, 6 by 10, it means SB divided by total number of S into left entropy plus the total number of records in like right node divided by total number of records in the entire node, 4 by 10 into 0.80. 0.80 means like entropy of right side. So if the calculation is done and we found here the total entropy, if you can see here, once the calculation is done, we found like 0.95 minus 0.36 plus 0.32 equal to 0.95 minus 0.68 equal to 0.27. Hence, it seems low information gain. Low information gain, why I am telling, if you see simply, the entropy is found here like 0.27. 0.27 means like 27%. So for other features, if you see other features, if you see simply, there are various features here, like student feature is also there, occupation feature is also there, income feature is also there. These all are like independent features, and for each of the feature this information gain has to be calculated. If any information gain is found which is more than age feature, information gain of student and information gain of occupation and information gain of income, it is taken and it is compared which feature is having highest information gain, that feature will be selected first for the splitting purpose. So this is what the formula which is used for uh, deciding which has to be node, like root node, and which has to be decision node. So information gain of all features are taken. Which information gain is more, that feature will be taken as a root node. I have already explained. After that, for next split, again information gain is calculated for rest of the features, and which feature has more information gain, that will be selected for splitting purpose, as already I have explained. If entropy is higher, then low information gain. If entropy is lower, then high information gain. I have already shown, if you see here 0.95 minus here 0.68, that is 0.68 is the entropy. Entropy is higher, that's why we are getting low information gain. If this entropy is lower, then we must have received high information gain. So if entropy is higher, then it is low information gain. If it is lower, then we can get high information gain. In this way, we say information gain is how much entropy did we remove out of total entropy. So it is quite clear that first entropy of the total node is taken, out of which information gain is like calculated by removing the entropy of its subset. So this video is enough for information gain, and we understood how information gain is basically works, and this is the formula which is used in like understanding information gain. While implementing decision tree module or decision tree algorithm, we do not have to write anything because this formula is internally used in decision tree. Simply we have to call the decision tree library, like we have to call the decision tree model, and we have to implement that. Automatically it will understand the data and it will make the decision. I will be coming up with a different video in which I will be explaining you like how Gini coefficient is calculated. If you like this video, please share and subscribe. Thank you so much.